electrical components, RLC. R stands for resistor, L stands for inductor, and C stands for capacitor. Now we are going to discuss all these elements. First of all, what is a resistor? Resistor is generally used to oppose the flow of electric current, while inductor has two properties. One application of inductor according to its property is that it stores energy in a magnetic field, while the second application is to oppose the flow of change in current. As the resistor opposes the flow of electric current, while inductor opposes the flow of change in current. Now capacitor is a device which is used to store the energy in an electric field, while it is used to oppose the flow of change in voltage. Now coming to the symbols of all these electronic components, this is called a resistor, this is called a inductor or a coil, and this is called a capacitor. Now we are going to discuss all of these elements one by one. Resistor. Resistor is a passive electrical two-terminal component which is used to oppose the flow of electric current, and it also implements a resistance of the electrical circuit. While resistance is also defined as the ratio of voltage or the ratio of the magnitude of voltage to the intensity of current in an electrical circuit. The relation of resistor or the relation of the resistance of a resistor is given by Ohm's law, which we have discussed in the previous video, that is V is equals to IR. The Ohm symbol is drawn like that. Is defined as the volt per ampere types. There are mainly two types of a resistor. One is called fixed resistor and other one is called variable resistor. The resistors that are categorized in fixed type resistors are film resistor, carbon composite resistor, wire resistor or resistance wire, or wire wound resistor. These four types of resistors are categorized in fixed resistors, while coming to the variable resistors, rheostat, varistor, photoresistor, thermistor, humistor, these are all types which are categorized in the variable resistor. Now coming to the power rating of a resistor, the power rating of a resistor is given by the formation P is equals to VI, which we have discussed in the previous video of Ohm's law, which defines the product of voltage and current is known as the power. From the equation we can say that the higher the power rating of the resistor will give the greater size, or we can say the greater physical size of the resistor. Now connections. Resistor can be connected in the form of two circuits. One is series circuit and other one is the parallel circuit. Now in series circuit, R is equal to R1 plus R2 plus R3, while in the series circuit the current remains same, that is I is equal to I1 is equal to I2 is equal to I3. This is the formation we are given in which three resistors are connected in series is So if three resistors are connected in series, so the equivalent resistance of the resistor will be equal to the individual resistance of individual resistors. Now coming to the very peak points of that series circuit, we can say that whenever the resistors are connected in series, the equivalent resistor or the equivalent resistance of the resistor will be highest than the higher value of the individual resistor. Let's suppose if R1 is equal to 1 ohm, R2 is equal to 2 ohm, R3 is equal to 3 ohm, then the equivalent resistor which is connected in series will be greater than 3 ohm. That is the highest value of the individual resistor. The second point, we can say that the current flow through the series circuit is same. The voltage across the series circuit will add up here. V is equal to V1 plus V2 plus V3. Now moving towards the parallel circuit, the resistors that are connected in parallel will give the equivalent resistance of the resistor is 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. The current in the parallel circuit will add up like I is equal to I1 plus I2 plus I3. The voltage across the parallel resistor is same. We can say that the equivalent resistance of the resistor connected in parallel will be least than the least value of an individual resistor. Let's suppose if R1 is equal to 1 ohm, R2 is equal to 2 ohm, R3 is equal to 3 ohm, then the equivalent resistance of the resistor connected in parallel will be the value less than 1. That is called is the resistor that are connected in parallel. Capacitor. Capacitor is a passive device which is used to store the energy as well as it opposes the flow of change in voltage. It consists of two plates separated by an insulated material which may be air or anything, and which will define the type of that particular capacitor according to the insulating material. The unit of the capacitance of a capacitor is farad, but mostly the capacitance of a capacitor is defined in microfarad, that is 10 raised to power minus 6 of a farad. Connections. As far as concerned with the resistor, capacitor may also be connected in series, parallel and series parallel circuiting. Now series circuiting. Whenever we connect the capacitor in series, the value of equivalent capacitance of the capacitor will be given by 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. That means that the value of reciprocal equivalent capacitance will be equals to the reciprocal sum of individual capacitance of a capacitor connected in series. Let's suppose if C1 is equal to 1 microfarad, C2 is equal to 2 microfarad and C3 is equal to 3 microfarad connected in series, the value of equivalent capacitance of a capacitor will be less than 1 microfarad. The current across the series circuit is same, that is I is equal to I1 is equal to I2 is equal to I3. The voltage across the charge across the capacitor in series connected in series will be the same, say if Q is equal to Q1 is equal to Q2 is equal to Q3, while the voltage across the series circuit will add up, that is V is equal to V1 plus V2 plus V3 in volts, as there are three capacitors connected in series. Now parallel connection. The value of equivalent capacitance of a capacitor connected in parallel will be given by C is equal to C1 plus C2 plus C3. Let's suppose C1 is equal to 1 microfarad, C2 is equal to 2 microfarad and C3 is equal to 3 microfarad. So the value of equivalent capacitance of a capacitor connected in parallel will be greatest than the greater value of the individual capacitance of a capacitor connected in parallel, so that it will be greater than 3 microfarad. The charge across the capacitor connected in parallel will add up, say as Q is equal to Q1 plus Q2 plus Q3, and the voltage across the parallel circuit is same. Types of capacitor. Capacitor are also of these two types. One are fixed capacitor and other one are the variable capacitor. Now charging and discharging of a capacitor. Now the graph of charging of a capacitor will be drawn with respect to the time to the charge on capacitors. You can see the graph as the parabolic curve which is going up, and at a certain point here shown that how the charging is completed of a capacitor, where you can see the fully charged dotted line. When the processing is going up, when with respect to time the charging is going on of the capacitor, then it is charging of a capacitor. Discharging of a capacitor, when our capacitor is fully charged and we are using the charge of the capacitor. So charge on capacitor, the graph will be same as between the time and the charge on capacitor. You can see a hyperbolic curve is over here which is going down, and when it will be come to the very flat and very down, then the capacitor will be fully discharged. Otherwise this process is showing the discharging of capacitor. Working of a capacitor. Capacitor is made up of two plates separated by an insulator. So we can say that there are two plates, one is positively charged and other one is negatively charged. On the left side of the plate, electrons are over there, and on the right side of the plate, the holes, that is positive material, is over here. When voltage is applying on the capacitor, the negatively charged electrons are pushed towards the positively charged. So the leaving of that electrons will make an excessive amount of current, which will show the charging of the capacitor. This is showing the interchanging of the working of the capacitor, so that capacitor is working on the principle of positive to negative contamination of electrons from one point to another point. So that's why that is the working of a capacitor. What is dielectric? Di means two, electric means electrical properties. A dielectric is a material which has two electrical properties, that is a conduction as well as insulation. It firstly works as an insulator, but an excessive amount of voltage is passing through it, it will convert into the conductor. Say if there is wood whose electrical dielectric property is up to 3 kV per 1 kV per millimeter of air, 2 kV per millimeter, 3 kV per millimeter, or rubber 4 kV per millimeter. It means that when an excessive amount of voltage is passing through that dielectric, it will give the property of conductor and current will pass through it. Inductor. Inductor is a passive electrical component which stores energy in the form of magnetic field as well as opposes the flow of change in current. Inductor may be consist of a wire or a loop or a coil. The inductance of an inductor will increase as the increase in number of turns. The symbol of inductor is shown in figure. It is denoted by L. Its unit is Henry. It is measured in Henry. Now see here how the turns are made over a coil. Now let's suppose this is a cylinder or anything. If we are going to find, this is called 1 turn, then this is 2 turns, that is 3, and that is 4 turns. So how much we are wounding, that are the number of turns increases, and number of turns are shown by the we can say N. The force on a current carrying conductor will be denoted by F. So F is equal to BIL, where B is the magnetic field of magnetic induction, or we can say that magnetic flux density. I is the current and L is the length of the conductor. As shown in figure, the cylinder, number of turns of a wire is wound over a cylinder. You can see the area of a cylinder as well as the length of the conductor and the number of turns, the force over a force in Newton onto a cylinder. So that all about the inductor values and inductors. The inductance of an inductor also depends on the material which is used. Inductance will be increased or decreased according to the particular shape. Types of inductor. These are the following types which are coming one by one. That is ferromagnetic iron inductor, powdered iron inductor, and air inductor, laminated core inductor. After that we can also, many types of inductor are over there. So these are the types of inductor. Working of an inductor. Now as shown in figure, the graph is drawing between two parameters. Then you can see that how an inductor is working. The inductors are used in tube lights, or we can say that any inductive load used in the home. Now what is magnetism? That any material which has the property of magnetism is called a magnet. Now magnetic field in a current carrying conductor, because magnetic field is always produced when the charge is moving, but when the charge is static, here we called electric field. That is the major difference between electric field and magnetic field. Now summary of the topic. We have seen the resistor, inductor, capacitor, their connections, their types, and all these contents. So finally we get the solution that resistor is a static material and capacitor is used to in the electric field, while inductor is used in magnetic field, and capacitor is used to store the energy in electric field and opposes the flow of change in voltage. Inductor is used to store the energy in magnetic field and opposes the flow of change in current, while resistor is used to oppose the flow of electric current. And we can also say that these all resistor is used in AC and DC circuits, while impedance in AC circuit will be equals to the equivalent DC resistance, while capacitor and inductor are used in only AC circuits. They are not used in DC circuits because cycles are over there with